Hello and welcome to Embedded Internals. This is 8th episode of our series C System Fundamental series. Until now, we have seen how the bits store information, how operators transforms value, and how bitwise operators can manipulate representation. Now is the time when we should know how does C know how many bytes to read, store, compute, and convert. Let's start by knowing what is a type really. We know we have different data types storing values, character, char, 1 byte, float, 4, double, 8 byte. Similarly, so on. All these data types can be signed and unsigned as well. Signed means complete range from 127 to plus 128, taking MSB as a signed bit. Unsigned complete 2 to the power 255. For the character, integer will go on 2 to the power 32, right? This range will be for the character, 1 byte of range. We think that when we are declaring the data types, integer, cat, float, they are like the storage containers, but actually they are not just the storage container. When we declare any type, it tells the compiler how many bytes it needs to store, how to interrupt the information, how to interrupt the variable, or what operations are valid, and how arithmetic will behave on that data type. Like when we are dividing and any remainder will not be represented when we are using integer data type, whereas in the case of float we will get the remainder output as well. So it seems that the data type tells the compiler that how arithmetic should behave. Therefore, we can say that data types are not just the storage container, it gives lots of information to the compiler. At the programming level, we have all the representation can be in any format, binary format, hexadecimal format, or any other format. Whereas we should always remember this, that memory only contains bits. At memory level, we will talk into the binary representation, that is in the bits. Whereas at the upper level, memories are represented in the byte format. Compile time and runtime. When we say compile time, it is where compiler checks do these checking like type checking. So data type checking happens at the compiler stage only. Size of, valid size of, layout rules or conversions rule, layout decision, and conversion rule, like how the binary decimal will be converted into binary and all those things. This is compiled. These all things happens at the compile time. Whereas when we are saying runtime means our program is already in the execution mode. So parameter related to execution checks at execution time. Memory is being read at the execution time, and CPU instructions. Program is already running. So memory, CPU instruction, and all the relevant commands related to execution will come into picture at the runtime. Like when we say size of int, at the compile time only compiler knows that it has to allocate 4 bytes to this variable, or what will be the output of this statement. Whereas when we are doing some malloc operation, malloc 1, so just virtual address space we have allocated this memory, but at the physical level during the runtime this operation will be get performed. So this is a dynamic allocation, it happens at that runtime. So things which are usually computed before the program runs is actually that is mean by compile time. Whereas when the program is actually running, and that time we are checking the memory, CPU instruction, or any execution related things, that is that term or that operation we are terming as runtime. We have one size of operator. Size of operator. This is one of the most important operator in C. Syntax is simply size of, give the data type or any object. Size of always returns size in byte. Size of the data type in bytes. Like, just see one example. This is a very simple program where we have declared one local variable and printed the size of that variable. Let us print the size of variable only. So size of a, cc size of dot c 4. So size of integer is 4. A corresponding to integer variable, so size of it, we will get the size of data type. You can just print size of int only. Similarly, if we have to print size of any other data variable like size of char, size of float, unsigned char, or double. Let us take the size of pointer variable as well. So let us print now the value of a. So size of integer typically is 4 bytes, character 1 byte, float 4 bytes, signed character 1 byte, double 8 bytes, while pointer is 8 byte. Pointer can be of any data type like pointer of integer, character, float. Every time pointer we are pointing to the address, so size will remain same, that is 8 bytes. This is how we can print size of any variable. Now let me do some changes. If I can print the size of variable as this, like 10 or 20, let me increase the value of this. What will happen if at the place of 10, I want to print the size of some integer range, 10,000. Will the size remain same? 4. Size of integer we get. If we are doing some operation, like let me do increment operator at the size of level. Does it perform any operations as well? By this we are just checking. Let me delete it. So we have declared a variable a, local variable a, having some 10,000 or some values, and then we have done some operation over that variable. I want to know if size of performed that operation or not, or what output we are going to get here. Size of is just calculating the size of data type. It is not doing any kind of operation. So if we want to find out the size of a array, like a is an array of 10 character. A is an array of 10 character. I want to find the size of array. Will it do the computation? I just want to know. 40. So array of 10 means integer. One integer is 4 byte, and typically we are storing for the 10 character 10 continuous byte of memory, so it will become 4 into 10, 40. If we want to know only the size, if we want to know how many elements are present inside the array, size of a will give the complete array size, that is a is 10 into 440, and size of a of 0 means size of first element, that is 4 bytes. So 10 divided by 40 divided by 4, that is 10. So that will give the size of total elements present into the array. This formula is going to give you total elements present in array, that is this. First thing, we can find size of any data type using size of this data type inside it. So it will return the size of that data type in bytes. Similarly, we can calculate size of any variable. If we give the variable name, then it will return the size of data type variable is of. Size of int, if it is int a is equal to 10, so size of a will give size of the data type it is being represented by, so it is of integer. Second thing, size of does not do any kind of computation. Any kind of computation is not present in size. So if we are going to do size of a plus plus, so this expression will not be evaluated, only we will get the size of the variable data type, that is 4. Size of any pointer is always 8 bytes, or the memory which is represented inside the architecture, inside our architecture, typically 8x4 pointers. It doesn't matter which type of pointer it is, if it is integer pointer, character pointer, or float, double, any kind of pointer it is, but sizeof is always return the size of pointer, that is 8 byte. We can calculate size of arrays and element of size of, we can also find out the total number of elements present inside the array. Array will give the total size. Like if we have an array, integer array of 10 elements, then size will be become a into 10, a integer data type, so 4 into 10, that is 40. Also, size of does not depend upon the value. Like size of a, if it is 10 or 10,000, remains same if that is in range. So no competition is so size of does not measure any value. Size of does not measure any value. Size of, if we have to calculate size of variable, this is one of the most interview asked question, that how can we find out the size of a variable, a size of one data type, without using the size of operator. So like this is our stack segment, and it contain a is equal to 10. So this is the upper limit and this is the lower limit address. So address of lower to minus a plus 1 minus address of a plus 1 higher range minus the lower range will give you the size of. So if the address at the lower range is 0 into something into 40, and address of 0 into higher range is 44, so 44 minus 40, we will going to get our size. Okay, that is 4. So one more point, so few points in size of is that if we have a declaration of character C, integer X, double D, we also have to very much sure about the how it is represented inside the memory. Let us check. Possible size of will return 1, 4, double is 8 bytes. Possibly when we will see in the memory, address will, let's see, 1000 or 1004. So there is a difference of 4 byte. Now 1000 C, 8 byte difference. So like this. Here the character C will come, there X and there D. So it is representing how many memory address actually it is taking, how many bytes. When we are using array inside a function, then array becomes pointer. That time size of will going to return the size of pointer size. Okay, like we have one function void f of f function, and here we are passing array as a parameter, array of any size. And if we want to calculate the size of here, array when we pass as a argument, it becomes pointer. So this time size of will going to return the size of pointer, that is 8 bytes mostly in most of the architecture. Okay, let's move to cast operator. Cast means ask compiler to reinterpret or convert. Like the typical syntax is like a type, this is type casting or any value. Like we have an character or we have an integer a, b. If we want integer to be casted as character, so we will simply do char a. So now a, which is an integer variable, will be treated as character variable. Okay, for let us I will give you an example. Second example, we have a float variable. float x is equal to 3.9. Float means with pointer. Okay. If we want to print only the integer, if we want to treat it like a integer, like %d, let us print int x, then the value will become simply integer part, that is 3. Fraction will be removed. So cast is a parameter by which we can convert any data type into any other data type as well. Float is converted into integer by using the typecasting operation. Let us see few examples of typecasting. We have a float variable a, its value is 6.5. And if we want to typecast print only the integer, let us do typecasting of a int of this. Return 0. Return 0. Okay, this is a very simple program. Let us see the output. First, where we have printed the float variable, we get all the details. We get the output in fractions. Whereas in the case of typecasting, we just get only the integer part. So fraction part has been removed. This is how the typecasting works. When we are doing any kind of malloc, malloc returns void pointer, generic data type void pointer. If that time we need to typecast mostly into our valid data type like integer, character, anything. So in that case, we use typecasting. And in most of the in other cases as well. Like I hope you remember, mostly for the malloc, we first do sizeof int any number of variable we need to allocate, and then we do typecasting. This is of integer pointer because malloc usually return void pointer data, that is a generic data type. So it needs to be typecasted into some character or some valid data types. That time we used this typecasting operator. There are typecasting can be of two type. Implicit, which is done automatically done by the compiler. Implicit conversion and explicit conversion. Like in this example, programmer is doing the conversion, automatically done by compiler. Sometime because of this, we have a chance of data loss, manually done by programmer. Implicit is like int is converted into double. Int inside converted into double. So for example, let me give you an example. We have an operation. We are just printing a value float of f, that is 5 plus 2.75. So 5 is an integer and this is a float or double float variable, or we can say double precision meter. So the output will simply become 7.5 based on some level of precision. So integer has been converted into double to perform this operation, and this is automatically done by the compiler. This is termed as implicit conversion, which is automatically done by the compiler. And here also conversion hierarchy matter. Lower get converted into higher data type. So we have seen what it mean by casting, how one data type get casted into other, larger or higher data type get converted into lower data type. We have taken one example where generally or mostly we have to do the typecasting, that is malloc. And typecasting are of two type. One is implicit typecasting and other is explicit. Implicit means which is automatically done by compiler, whereas Explicit means manually done by the programmer. Like we have taken one example where integer has been converted into double. There also conversion hierarchy matter. Now comes what are the problem we face when because of this typecasting. So dangerous casts. By typecasting, it doesn't mean automatically or magically data fits from one type to another type. It is not any magical fit of data. For example, we have an integer variable a having some value 300. Okay, we are trying to cast this value. We have one character variable. We casted this a integer into character. Possible result 300. 300 will be in the binary format represented as, so it will become 300. When we have done the typecasting, so first values get casted only. So integer is a 32 bits data type. We only have the sufficient memory to hold for a 1 byte of data. So this data will copied and this data got lost. So when we are doing typecasting from the higher data type to the lower data type, there is a huge chance of data lost. So a is 300 and we have typecasted that care of a and print the value of a 44. So only the first byte, 1 byte of data we are getting data. So we are saying there here we are, because of typecasting we are saying the information loss. This is an example of loss information. When we have to take an example of overflow, we have a variable double d1e00. Double has been converted into integer. Let's see what will be the output of this. See, this seems to be a overflow of information, minus of something, data overflow. So these two, because of typecasting, sometime there is a chance of data overflow, sometime there is a chance of data loss as well. So we should be very careful when we are using the typecasting operator. So it's the user responsibility, programmer responsibility to take care of these scenarios. And we have typecasted it into like character pointer. So now bytes can be interrupted differently. In the memory, 65 will be represented as, so while reading the first bit for 65, so it is, the memory representation of this will be this and all 0. Similarly for this and this also all 0. So this will become 0. 2 to the power 0 is 1, 2, 4, 8, 16, 32, 64. This is 64 plus 1, 65. And this is in the hexadecimal format. We are representing it as 41. So in the memory, it will be represented as this. So it can be 65. It can be 41. It can be have some other floating point number. So by pointer typecasting, we are just reinterpreting the bytes differently. Okay, so pointer typecasting is basically reinterpretation of data. After the size of variable and the typecasting, let's move to type safety. System prevent mistakes. Basically, to prevent the mistakes related to data type, we have type safety mechanism. Few points we always need to take care, and it's mostly of the programmer responsibility. So like when you will declare int x is equal to hello, you will get the compiler error because hello is a string and string are mostly of the char pointer type. So when you declare the same variable hello as char pointer s or any variable, it is okay. So C gives us lots of power, and with power we have lots of responsibilities as well. We have an integer x is 5. Okay, we have a float pointer. First looking, it seems okay, there is no problem. We have an integer variable, we have just typecasted into a float pointer, and pointer are of same size, so it looks harmless. But underline, it can create undefined behavior. We don't know how the memory can be treated here. So it can lead to undefined behavior. We will see what is undefined behavior in our next episode and in which cases undefined behavior can occur. In this episode where we have checked that size of operator, typecasting operator, and why type safety is needed and how it is the programmer responsibility to ensure the safety. Along with we know that compilers has given us lots of check before moving forward. We see from the compiler perspective, compiler always track data. User declare a variable, whereas compiler tracks its type, size, alignment, conversion, and layout. Everything compiler check. Whereas when we talk about the CPU terms, so same variable, how the compiler is treating it and how the CPU is treating it. When we go to the at CPU level, we are talking in terms of bytes, instructions, and registers. So it's not just declared a variable, it's how the compiler is tracking it and what is actually happening when we are going at the CPU level. So they are largely compile time abstractions. Therefore, its safeties are very important. So we know that memory stores byte, but types define interpretations. The same memory byte can be reinterpreted into different forms. So now we understand what are sizes, types, and conversions and why type safeties are required. In the next episode, we will enter the deepest part of C, that is, how expressions are evaluated, how compiler reasons, and how undefined behavior changes reality. Stay tuned for same. Thank you.